Advanced Lesson 5, Algebraic Expressions and Equations. Let's first review the rules for exponents. Product rule says that if you're multiplying the same base, that you add the exponents. So just a little example of that. Let's say that we have x cubed times x squared. Add the exponents, you get x to the fifth. Quotient rule, if you're dividing the same base, you are to subtract the exponents. So if you have x cubed divided by x squared, it's going to be x to the first. 3 minus 2 is 1. The power rule says if you have an exponent to an exponent, you multiply the exponents. So 3 times 2 is 6. This example, x cubed to the second would be x to the sixth. Number 4, the product power rule. I actually call it the power of a product rule. If you are multiplying two things that are raised to an exponent, and then that in turn is raised to an exponent, you can apply the exponent to each of those things that you're multiplying. So x squared times y cubed to the fifth is going to be x to the 2 times 5, which is 10, times y to the 3 times 5, which is 15. Number 5, the quotient power property, or power of a quotient, says that if you have a fraction and the top and bottom have exponents, like x squared over y cubed, and that in turn is raised to an exponent, like to the fifth, you can apply the exponents both the numerator and denominator. That would be x to the 10th over x to the 15th, because you multiply the exponents. Number 6, negative exponents. Essentially means that if you have a number to a negative exponent, you can make it a positive exponent by reciprocating the base. So for example, if we had 3 to the negative 1, it's going to be the same as 1/3 to the first, which in this case would be 1/3. Other fun facts: any number to the first power is that number. Any number to the 0 power is 1, as long as the number you started with is not 0. Let's do some real examples here. Rational expression is an expression that has a radical in it. Rational expression, not radical. A rational expression is an expression that has a rational number in it, and a rational number would mean that it has a fraction in it. Adding and subtracting rational expressions. To add or subtract, you need common denominators. That's the bottoms. If they're the same, you add or subtract the tops. So 2x minus x is going to be 1x. Denominator stays the same. Number 2, adding. They already have common denominators. So you add the numerators, combine like terms. A squared has no like term. Plus x, those are like terms. You're going to get plus 2x. Denominator stays the same. If you can cancel anything from here, if you can simplify your fraction, you should do so. And that happens when you can multiply the top and the bottom by the same thing, which would make your problem simpler, or divide the top and bottom by the same thing, would make your problem simpler. Number 3, more complicated because we do not have common denominators. So to get common denominators, we're going to multiply the first fraction by 1. We're going to multiply it in the form of x over x. Remember, when you multiply something by 1, it doesn't change its value, it just changes the way that it looks. I'm going to multiply the second fraction by 1 in the form of y divided by y. So my first fraction is going to become 2x squared over xy. My second fraction is going to be 3y squared over xy. Now that I have common denominators, I'm going to subtract the numerators. If the top would factor, we would factor it. See if we could cancel something from the bottom, but it does not. So we are finished. Okay, moving on to number 4. Multiplying and dividing rational expressions. When you multiply two fractions, you multiply the top together and the bottom. So number 4 is just 6 over xy. Number 5, multiply the top together. We have an x squared and an x to the third. You add the exponents. We have a y cubed and a y squared. You add the exponents. Our denominator, we have a y and we have a z times z, which is z squared. That could simplify. You would do so, but we cannot divide top and bottom by the same thing other than 1. Number 6, when you're dividing a fraction by a fraction, you can instead multiply the first fraction by the reciprocal of the second fraction. Reciprocal means you make the top the bottom and the bottom the top. Now this is just going to be multiplying two fractions, which is 3y over 2x. Number 7, I'm going to leave the first fraction the same. Instead of dividing by the second fraction, we are going to multiply by it. Now, if we can cancel some things, let's cancel some things. Z divided by z is 1. X squared, you can divide by x squared. It goes 1 time. It goes into x cubed, x times. And you can divide y cubed by y squared. It goes y times. Y squared into y squared. It goes 1 time. So we are left with w y over x. Radical expressions. That's when you have a square root. Should be noted that whenever you have a square root, such as that we have here, and then the exponent inside the radical is the same number, those are inverse operations, you're left with whatever the base was, which is a 2. Number 9, we are square rooting a negative 2 squared, so we get negative 2 for our answer.